And where'd you get shot from? I think, look at, where did I get Greeley from? Did you see that I did my homework the day that I told you I was going to?
I think I saw that.
Oh my gosh, I actually did my homework over the break. That's crazy, too. Actually, no, I didn't. I forgot that we had homework. And so I did it. I did it last period. No, I did it in second period. I
As long
forgot.
as it's in the box on time, that's all I care about.
Yeah, it's in the box right now.
All right. Seth, make sure you're doing your homework.
Yeah, it's.
Friday, you didn't turn on anything Friday. Would have been 4.1B. You didn't turn 4.1.
Let me check.
I remember you because I remember you. I think Seth was the only one that didn't turn it on Friday.
I don't know if I turn them.
You did. I remember because I put it in the grade book this morning.
I've got a 4.1B in here. I got 4.1.
That's fine, I'm just saying.
That's the one that's due today. Make sure that gets turned in.
4.1B.
All right, so I'm assuming there's no questions on 41C. That was just practice.
I have a question on it, but I don't want you to do the actual math at all. I'm just wondering if it's like some number in parentheses, x squared, and then plus or minus some other number,
Right.
College.
and it's to the second.
Yeah.
Is this a 4 to the 4th degree?
Only if that's a minus. Because if it's a plus, it can't be factored.
Okay, so.
So like
if it's
you can't factor
one-
x squared plus 4. You can factor x squared minus 4.
So it'd be
Yeah,
the degrees.
that degree there's 4, yes.
Okay.
All right. Okay, so what we're gonna do today, we're gonna do something,
Different.
Similar.
very similar. It's also easy, but it has lots of steps. But I'm just gonna tell you that there's nothing we're doing today's chat. In fact, we're doing absolutely nothing new today. We're gonna use stuff that we've already done before, but we're gonna put it together in a different form. All right. I've got a quiz on Thursday. I'll talk about it tomorrow and Wednesday. Homework tonight. And I should, Evelyn, make another statement. So x squared plus 4 has no factors in the real number system.
Did I put x squared plus 4?
Well, you put plus or minus, so if it's x squared minus 4, yep, that's factorable.
So it
X
has
plus
to
2,
be-
x minus 2. Well, it's not going to have any roots if it's x. No, it's not going to have any what are the term real roots if it's x squared plus something, because that can't be factored in the real number system.
It's crazy how it's almost November.
I know. We got 5 weeks to go until Thanksgiving, and then 3 weeks after that, it's Christmas. That's crazy.
Congratulations.
All teachers that teach seniors or have had you kids always come to graduation.
I'm really glad they're not
doing
Am I gonna cry? Probably not, but it depends what the person I'm talking to. Like, if someone I'm talking to is crying, then I potentially could cry. But I'm not gonna jump up in joy and like, woo, thank God those guys are gone.
Is
Have
this
we
one
been?
standalone lesson or your part savings?
This is just one lesson. You're gonna see this. Today's a pretty, I mean, it's really like a 20-minute class too, so it's really quickly done. Depends on how many questions you ask and if you get it immediately. I would say half of you will get it immediately. The other half need a minute or two to wrap your head around what's going on. All right, so I said we're gonna do something complicated that's easy. I've never seen one of those. That is cool.
They have them so you could print them on books.
That is
So you
cool.
don't have to write in books.
All right, big picture. What are we doing in this chapter? Remember, the big idea in this chapter is I'm going to hand you a polynomial that isn't factored, and you have to graph it by hand. Right? So we're slowly working our way up to that. We said we had to build up a lot of skills before we can do the whole thing by hand. Today we get another skill. Okay. And the skill today is putting together all the stuff that we've learned so far. And that's going to allow us to do these graphs. Okay. All right. Big picture. All right. Last class, we talked about the graph of a polynomial using transformations. I gave you a graph. You wrote it using its real roots, its multiplicity. We talked about the knowledge of power functions. We talked about real roots. And we talked about turning points. Of all these, there was only one formula, and that was the formula for turning points. Anybody remember? My other class couldn't remember this one. It was too long ago. Formula for turning points. Anybody remember? It was an easy formula.
It's n subtract 1.
N subtract 1. Well done. N subtract 1. Remember, that tells you at most how many turning points. Of everything we do today, this is the one, turning points, that you got to be able to wrap your head around. What is a turning point? It's a local min or max where the function changes from going up to going down or from going down to going up, right? Finding a turning point is easy, but wrapping your head when we start doing this thing called turning points, wrapping your head around this concept, right, is the most challenging thing we'll do today. All right. We also talked about the degree of the polynomial. Remember, the degree of the polynomial is find the highest power of the function, and that's the degree of the polynomial. Today's class, we're going to graph a polynomial function again. It's just isn't going to be in transformational form. It's going to be a non-transformational form, right? Remember, we're graphing it by hand. We can use a calculator to check our work, but please just use your calculator to check your work, not to do your work. All right, you ready? I said this is going to be, so it's going to be easy, but complicated. All right. So a lot of steps. Remember, I'm going to hand you a polynomial that's not in transformational form and ask you to graph it by hand. Well, no, we're not going to use a table of pain. So recall that the parent functions of polynomials, we're talking about power functions for polynomials, they only come in two flavors. What two flavors?
Positive or even and odd.
Even and odd. And so remember, for an even one, that means the highest power is an even power. And the basic shape is, for even, it's a parabola, either concave up or concave down. How do you make a concave down parabola? Yeah, but how do you make it? What's negative? Yeah, I'm going to disagree with that. The y value is negative. In other words, the outside is negative. Now, you're not going to see me put parentheses, but if you have parentheses, the negative is on the inside, that's the x is negative. On the outside, we're saying the whole function, negative f of x. Okay? So yes, it will look like that right there. And it is a frowning face, concave down. Okay, and that applies to every single power function that's even. If this is x to the 200th power, it's going to look like, well, the top one, except as the number increases even-wise, then the bottom kind of flattens out and the legs of the parabola kind of straighten up. They never go to full vertical. Okay, we've graphed these before, right? This is transformational form right here. We graphed this before, but today they're going to look like this. And so how are we going to graph that? Well, that's what today's on. Okay. Well, we know it's degree 4, so we know it's an even polynomial, so it's going to be concave up. By the way, this is the graph of that one right there. Okay. Wow, we got some work to do. The second type is the odd one. What's the basic shape of the odd power function? Kind of like an S, right? So like this, except it's not really an S, right? It is if you make it negative and then it looks like an S sideways, right? Tilt your head to the right, now it looks like an S type thing. Except we're not going to be graphing those easy ones. We're graphing this one right here. By the way, this is that graph. So this is what your homework will look like, the end product here on the right. It's going to be a picture of a graph that's either an even or an odd power function. Okay. So to do this, 5 steps. I wrote them down for you, box 1. 5 steps, right? You're going to have to be a mathematician but you're gonna also have to be a detective in order to do this. So really the hardest thing today is understanding the detective part, not the math part. I stated before, I've already taught you everything you need to know math-wise in order to do today's homework. I haven't taught you how to be the detective. So you need to wrap your head around the detective part today. So graphing by hand, there's 5 steps. You can read them yourself, right? Determine end behavior. We've talked about that before. Find the X and Y intercepts. We've done that before. Find the zeros. Determine if it crosses or bounces. Anybody remember this? This is called crosses or bounces. 2 nights ago homework, or 2 classes ago homework. This is called.
Oh, like if it's pointy or if it's good?
No, that's turning points. Or I'm sorry, that was cusp or corners. This was called multiplicity. Remember that? Multiplicity comes in 2 flavors. If it's even, and if it's odd, it goes through or crosses, right? And then turning points, we said, is the formula n-1. So all of these 5 steps, we're going to have to do a little bit of detective work in order to graph. Remember, ultimate goal here is to graph this polynomial function by hand. So it's easiest just to do one, and I'll stop. We'll do this as slowly as possible, or slowly as necessary. Everybody ready? Okay, so we're going to graph that one right there. Okay, what's step number 1 say? We got to determine end behavior. What does end behavior mean in your own words? What's end behavior? Okay, it has a little bit to do with that. I'm not going to go with that statement though. She said, is it an arrow or a dot? Yeah, that actually is end behavior as well too, but I'm going to talk about more formal sense. End behavior. That's how we determine end behavior. What is end behavior? Whether or not the function is even or odd, which means what's the end behavior? You're almost there. There's only 2 possibilities for end behavior for these polynomials. They're either going to be even or odd, but what's the end behavior?
Oh my God.
Think about the basic shape.
S or U.
So what's the basic end behavior?
No.
Well, remember end behavior we said as x goes to,
Is it positive?
as x goes to negative infinity, what's happening to the y? And as x goes to positive infinity, what's happening to the y? We said there's only 2 flavors. The 2 flavors are, there was your mouth that said it. You said odd or even.
Yeah.
So what are the 2 end behaviors for odd and even?
Is it the
End behavior, as the name implied, means what's happening at the ends. So what's happening at the ends? For even functions, what's happening at the ends?
Is that thinking that you wanted to sort of memorize the like infinity? Like,
I would like you to memorize that. Go ahead, Seth. Tell everybody else. If it's a parabola, that means then the ends are going up or down, right? How do we know if it's going up or down? What's positive or negative? The a value, the number in front of the x squared or x to the 4th or x to the 6th. If the a is positive, the end behavior is? Is Seth the only one that's got this? If a is positive, then the end behavior for an even function is up. If a is negative, then it's down. Because remember, these are just parabolas. Okay, Ish, you can't see this. I'm drawing a parabola now. Hey, what's the end behavior here? Down, right? What's the end behavior here? Up. It's just the basic shape. So that's for an even function. How about an odd function?
then it'd be
What are the 2 possibilities?
negative and positive.
Okay, so that means it's either going in that direction, right? So it's starting from down, negative infinity, and it's going in an upward direction, right? That's when a is. This is when a is.
Positive.
And what if a is negative?
Then it'd be flipped the other way?
then it would be flipped the other way. So that's the end behavior. All we're basically saying with end behavior is, where do the arrows point? So take a step back. Those are your two possibilities. And in fact, that's kind of four possibilities, depending upon if A is positive or negative. So the question is, what's happening on this function? What's its end behavior? We have to do the opposite of factoring. We have to not solve it, but
Unfactor it.
we have to unfactor it, right? So for this particular one, if they gave it to you in standard form, we could tell immediately. Well, this isn't transformation form. It's kind of like in between. This is called factored form. So they're handing us factored form and they're asking us what's the end behavior. Well, therefore we need to know what's the leading term. So to find the leading term, what do we have to do? Say the word. We got to unfactor it. Okay, so how do you unfactor this thing? She says do x minus 3 squared first, which would be
X squared subtract 6x
plus 9. Okay. Now what? So we need to take this trinomial, x squared minus 6x plus 9, and multiply by 2x plus 1. Two methods, distributive property or stacking. I don't care which one. Which one? Distributive property. Okay, so distribute the 1. That's easy. So that'd be x squared minus 6x plus 9 and distribute the 1. Now distribute the 2x, and that would give us 2x cubed. I'm going to put that right here. So I'm going to put that right here.
plus
I'm going to put that right here. And then I'm going to draw a line and add, and we get
2x minus 11x squared plus 12x plus 9.
Yay, we get that. Okay, all we're doing is unfactoring. We're multiplying or we're squaring first, and we're multiplying. I don't care if you use the distributive property or you stack, get to that. Of this, what do we care about? Step 1, end behavior. Of this, what do we care about? The what?
The highest.
So what is the highest power there? 3. So therefore, this is an odd function. And then we also care about the A, and the A here is positive. So we now know with fingers which way this one goes. Which way does this one go? And then when X is going to, Y is going to, there you go. Well done. Okay, so we know it's degree 3. We know that the A value is 2, so it should look like 2x cubed. That's an odd power function where A is positive, so it should look like, you see the 2 arrows I just did? Those are placeholders. I'm not saying the function lives there. I'm just saying that's where it goes, where the arrows are pointed. One's pointed down and one's pointed up. And I'm getting that from this part right here. 2x cubed, 2 is positive, x is odd, therefore it looks like this. Now, if I'm really doing this for real, you'll see me, I'll do all the steps 1 through 4 first before I draw these little arrows. But I'm going to put the arrows right here just so that we can show you kind of like step by step by step. This will make more sense once we do a couple of these. We okay? What's step 2 say? Oh, we know how to do that. How do we find x and y intercepts? So to find the x-intercept, we plug in 0 for y. So to find the x-intercept, we plug in 0 for y, and we solve this one. All right, you can do this one in your head. Well, 3 for sure, and what's the other one? Close. You said 1/2, and I said close. Negative 1/2. Remember, the process is you take each zero product property. This times this is equal to 0. So we take each one, set it equal to 0, and we solve each one. So one on the right there, well, that's just 3. And the one on the left there, negative 1/2. Subtract 1, divide by 2. Did I lose anybody on that? Would I really do this for real, this part right here? No, I would just look at that and say negative 1/2 and 3. That's my x-intercept. Okay? What's the y-intercept? Well, what are we supposed to do for the y-intercept? plug in 0 for x. She claimed it was 0, 0, but I got that 1 and that -3 they're still hanging out there. So that would give me you're adding instead of multiplying. 9. Okay. Everybody see where I got that from, Matt? -3 squared is 9. That gives me a 1. 1 times 9 is 9. Hey, did anybody notice we got a y-intercept of 9? Anybody notice something? Remember, the y-intercept is always the constant. So when you did this step, technically, you also found the power function, which is 2x cubed, the a value, which is 2, and you also found the y-intercept, which was 9. But yes, you can do this as well, too. Okay, so we've done now the first 2 steps. We've determined end behavior, and we've also found the x and y intercepts. Hey, if I find the x and the y intercepts, think this through, what should I probably do? Put those 3 points, x intercepts 2 of them, y intercept the other one, put them on the graph. So I did that. Okay. By the way, those points live there. The 2 arrows, they may not be where they actually live, but those are the right directions. Okay, what's step 3 say?
Find zeros and determine if it crosses or touches the zeros.
Hey, luckily for us, the zeros are the x-intercepts, which we just found, which was -0.5 and 3. We simply now need to look. Oh, here's what I did. I moved my arrows closer to the x-intercepts. Guess why? If there was another x-intercept, right? For instance, this one here on the left, if there was another x-intercept, then it would curve up like that, right? But I know that there's only 2 x-intercepts, which is why I know it doesn't curve back up. Same thing with here on the right, the 3, I can put the arrow right next to it now because I know it doesn't come back down. Otherwise, I would have found another x-intercept. Okay. All right. So what was our thought before?
Crosses,
It's that thing called multiplicity. For our x-intercepts, we look at their multiplicity. And remember, if it's an odd multiplicity, it crosses. And if it's an even multiplicity, it either touches or bounces, whichever word you want to use. I usually use the word bounces, but I think I write touches over here. So here was our x-intercepts, right? -0.5 and 3. So if we go to where we found the -1/2, it came from 2x plus 1. What's the power of 2x plus 1 on the outside? What's the power of 2x plus 1 on the outside? It's 1, right? We're not saying x is to the first power. We're saying the power of 2x in parentheses on the outside is 1. So therefore it crosses. And the power of x minus 3 on the outside is 2. Therefore it bounces. Okay? We're almost there. Okay? So let's see, if it at -1/2, does it cross or bounce? So I can go through this point right here and draw it like that. And then at 3, it bounces, so I can draw that right there. You see what I'm doing? I'm kind of sneaking up on the answer. Like I said, when you see me do the second example, I'm going to do all the work first, and then I will draw it. But I'm showing this step by step by step by step. All right, we're on second to last step, and the second to last step says turning points. And Evelyn said the formula was n minus 1, where n is the degree of the polynomial. What was the degree of this polynomial? 3, so what's 3 minus 1? So how many turning points does it have? 2 turning points. Okay, well, these are all the dots that we have on our graph. The y-intercept, it always crosses. It doesn't bounce off of a y-intercept. So it always crosses. Now watch as I draw this. So we know from right here it has to cross the y-intercept. But I got to get back to here. So clearly at some point I need to go down to it. So if I go down to it, guess what I just made? Guess what I just made right there? A turning point. Hey, where it bounces off of here, guess what you made? How many turning points was it supposed to have? 2, so guess what? You're there. That's the answer. Does that feel satisfying or unsatisfying? It should feel unsatisfying because of one thing. You see the one thing? Everything except for one thing is hard, fast, strictly, we found it. What's the one thing that's kind of a guess? The little black loop that, you can't see it, but I was connecting the red lines, right? So we know that the degree of this one, right, or it has n-1 turning points, so it has 2 turning points. When we connect the dots, we in fact found 2 turning points. The only issue is this, I don't know, turning point that's between x value 0 and x value 3. This turning point right here is kind of a guess. Does it go back up higher? It could. Does it turn before that? Does it turn at the y-intercept? It could. The issue is for right now that's kind of a guess. So 3.2, I'm sorry, chapter or section 4.2, the only thing that's kind of a unsatisfying thing is this one will loop right there. And we still know it loops, we still know it goes down, we still know it's a turning point, but we're kind of guessing where that turning point occurs. Tonight for homework, it's okay. They're all going to be like this. There's going to be one where you kind of have to guess where it is, right? So this is an unanswered question of where does it actually turn? We need some more skills. We just don't learn them yet in 4.2. Hey, can we just throw in some random numbers and, table of pain and get a closer estimate of where this turning point is? The answer is sure. Anybody want to do that? No. So we're just going to leave it as an unanswered part of the question of where is that last turning point? Cool. That's the whole process right there. That's the whole process. How do we know it doesn't have, I'm going to go back one. How do we not know that it doesn't have more loop-de-loops inside right here before it goes back down? How do we know that? I mean, it certainly potentially could have more loop-de-loops. Why do we know it doesn't have more loop-de-loops? Because it only has 2 turning points, right? Yeah, I can put as many loops as I want between them, but it's not right because we know it's supposed to have n-1 turning points. So tonight for homework, if you're trying to guess whether it has more loop-de-loops, count your number of turning points. It's got to be at most n-1. Could it have had 1 turning point? The answer is no. If you have 1 turning point, guess what you'd have to draw? If you had 1 turning point, guess what I just drew? I drew a parabola, and a parabola is an even function, not an odd function. Right? It says at most n-1. Well, we figured it was supposed to have 2 turning points. Well, that's at most. So could it have had 1 turning point? The answer is no, because that would turn it into a parabola. It's not a parabola. It's to the 3rd power. It's got to make that S-looking shape.
If there's only one x-intercept, but it has 2 turns.
Well, then you know it has a loop-de-loop in between. Has to. All right. Tonight for homework, yes, absolutely. You can type that into your graphing calculator, confirm that this is the shape, but I don't want you to do your homework on the graphing calculator, but absolutely positively confirm. Does that make sense? Okay. Table of pain is always a pain. Well, maybe it feels like that's a lot of steps. Couldn't we have just done a table of pain? Well, the issue is, yeah, if you know where all the loop-de-loops occur, the table of pain is actually a little bit easier. Right? You're just plugging in numbers. Obviously, a graphing calculator is even easier. But the issue with a graphing calculator or table of pain is you don't know where those loop-de-loops occur. So if that loop-de-loops occur at -40, and you're throwing in 0 and 1 and -1, you're never going to find those loop-de-loops. This is a process that's guaranteed you to find those x-intercepts, which leads you to where the turning points occur. All right. So all we're going to do now, that's the whole process. Let's just do a bunch of practice problems. Okay, ready? This is box number 3. Okay, well, step number 1, end behavior. There's only 2 end behaviors. It's even or odd. So which one is this? How do you know?
Because the first thing in parentheses is a 1, the second one is a 2, and the third one is a 1.
And if you keep that thought, yeah, I love it. If you add them all up, you get, I am guaranteed that the degree is 4, but we also need to know A, and that's the problem. So does that tell you what A is from doing her method? Certainly tells us the degree of the polynomial 4. You say, hey, look, the first parentheses has a power of 1, so that means x is only going to be the first power. Second one, x squared. Third one is just x. X squared times x is x to the 4th. Absolutely positively, that will tell you the parent power function. but it won't tell you what A is. Now, how do you know?
Because there's nothing in front of the axis.
So smart kids are gonna find a pattern here, and they're gonna say, well, since I'm only concerned with the first term, shouldn't I just multiply the things that are gonna be multiplied first? And guess what those things are?
Yes.
The first thing in each little parentheses right there. The only issue is you gotta remember that this middle one is squared, so that's not x, that's squared. So that would be x times x squared times x, and yes, that's in fact just plain old x to the fourth. So for those of you that understood that, use that. If you didn't, well, then you gotta unfactor the whole thing. X plus 3 squared would be x squared plus 6x plus 9. And then we got to multiply all those together right there. Long story short, I'm doing this in individual steps. We do, in fact, get x to the fourth. Of this entire thing, there's 3 things here we should care about. What are the 3 things? Wayne, are you with me? What are the 3 things we care about this right here? The 90, hey, that's the y-intercept. And we care about 2 things right here, the a and the power, okay? Most classes get to the fact that like, hey, that seems like a lot of work. Can I just do what Abby was saying? And the answer is yes. Other kids will say, well, it's worth it because we got the 90 and that's my y-intercept. I'll just say the other way of finding the y-intercept is easier than multiplying 3 trinomial or 3 polynomials together. All right, so we know it looks like x to the fourth. What's that shape? What's that end behavior? Seth is giving me the parabola with his finger for concave up. So yes, this one is concave up. All right, x-intercepts. You should be able to do this in your head just by looking at it. What are the x-intercepts? 2, -3, and 5. That's really quickly done, right? We said each one equal to 0, solve. No, you can probably do that in your head. But if you have to set that equal to, okay, cool. Y-intercept we just figured out was 90. But if you didn't do it that way, we would plug in 0 for x and then do that math. Well, that's going to be -2 times, careful, 9 times -5 times -2. 10 times 9 is 90. We already knew it was 90. Okay, cool. So we have our, what it should look like, end behavior, should be concave up. We have our x-intercepts. We have our y-intercepts. That's step 3. What's step 4? Turning points. So you take your x-intercepts and you, so at -3, it bounces. And at the other 2, it crosses. Was that too quick or all right? So at -3, it bounces. At 2 and 5, it crosses. Too quick or all right?
Okay.
All right, cool. Last one, turning points. N-1 would give us. N-1 would give us. You're not understanding N-1. N-1 would give us. Say it again, Matt. 3, right? The power is 4. 4 minus 1 is 3. So at most there are, but there also could be, he says 2, and I didn't agree with that. There, at most there could be 3 turning points, but there also could be, at most it's 3. So which one could it be? He said 2, and I said, I don't agree with that one. Why can't it have 2 turning points? 1, 2. Why can't it have 2 turning points? Then it would turn it into an odd one. Could it have 1 turning point?
Yes.
Sure could. There's 1 turning point right there. So it's either going to have 3 or it's going to have 1. Yeah, but at most it can have 3. That's what it literally means. At most N-1. But you're right, because if this had been to the 6th power, then it could have 5 or 3 or 1. So hopefully you don't have too many of those for homework. It has to be, yeah. So it's a paradox, right? So if it's an even function, it has to have an odd number of turning points. If it's an odd function, then it has to have an even number of turning points. Okay. And then you're just subtracting 2 from whatever the n minus 1 is. Can't have a negative number of turning points. Okay, so we're gonna put all that together to graph. I'm gonna graph my x-intercepts tonight for homework. You may have some weird ones. Look, I got a y-intercept of 90, right? We decided this was what? End behavior? End behavior. Step 1. End behavior was should look like x to the 4th. So end behavior is that you're giving me end behavior is where the arrows point. Where do the arrows point if it's x to the 4th? That would be odd.
What? Why would that be on?
Because you went like this.
Oh, it's up. Yeah, that way, so it's pointing to the right.
Yeah, but you said like this
Yeah,
with your hands.
oh.
X to the 4th looks like Seth is doing it like this, right? Negative x to the 4th would look like this. X to the 5th would look like this. Negative x to the 5th would look like this. Okay, Ish, you couldn't see any of that, but we were doing a little dance moves up here. X to the 4th, they both point up. Negative x to the 4th, they both point down. X to the 5th, they point in opposite direction from negative infinity to positive infinity, or for the y values, and then negative x to the 5th would be the opposite of that. So we know they both point in upward direction like that. It's x to the 4th. Okay. Well, starting from the left, if I'm coming in a downward direction, what do I have to do? I have this one x-intercept right here, which is at -3, and we decided at -3 it bounces off of that one. Then it's got to go to the y-intercept. You always go through a y-intercept. So it goes through the y-intercept. And then it crosses and crosses. Yeah? Okay. So now what do? How many turning points do we say? We're expecting either 3 or 1. So now we're just going to connect the red parts. If I connect the red parts, I go down to this little loop, up to the y-intercept, but then I got to go down to this crossing point, and then back up to the crossing point. So how many turning points do I have? Which is what I expected. I expected 3 or 1. That's the answer. Go ahead, ask your question. I'm going to go back to that.
Oh, you said it was gonna be.
What did we say?
Like, it wasn't gonna look like an odd, it was supposed to look like an even, but if you go back to the.
Oh, you think that looks like
Odd.
look at the end behavior.
Oh, never mind, okay.
The end behavior is they're both pointing in an upward direction.
And it goes up and down.
Yeah, and so as you get into
Yeah.
higher powers, you get all these loop-de-loops that can
Yeah.
happen in the middle. But the end behavior, which is why we start with that, tells you what happens at the ends, at x is equal to negative infinity and x is equal to positive infinity. By the way, doing this by hand, look, we had a y-intercept of 90. This loop down here, which you would just have to guess, we had no way of figuring where this one was down here. The second loop right here. It turns out, and this is the actual graph of it, turns out it's a negative 100. Now, you would not be able to find that. That's why this is slightly unsatisfying as an answer, because the only way to find this right now is do a table of pain. Plug in values between positive, 2 and positive 5 to figure out what you get. Yeah.
Why, in the last one, you made us. No.
Those are the best questions. Yeah. Once we do one together. Okay. All right. Yes. What was homework? What was homework? 6 through 22 evens, right? So pick one. Let's do one together. 8 looks like the hardest one. Oh, you're doing that one right now?
Wow.
12 looks hard? You're not even looking at them.
Here, let's.
You're looking at the answers.
I don't know, I just looked at one.
Which one looks challenging? 22 looks challenging?
Yeah.
We're gonna let Abby pick? Yeah. All right, read it out. Sorry, Ish, you can't see this, but I'll keep the video going so you can hear the conversation.
F of x equals x squared parentheses, x squared plus one, then parentheses, and then parentheses, x plus four.
X plus 4,
Yes.
looks just like that?
Yeah.
Okay, this actually is an easy one.
Oh.
All right. But it's good because it brings up Evelyn's question of at the start of class. Okay. Step number 1, end behavior.
2, 4, 5, it's odd.
So it's x to the,
No, we can.
Winter says to the 5th power, so she says odd. We going with that? X to the 5th?
It's even. I counted,
Even,
I counted wrong. It's an even.
How did you count wrong?
Because I counted the one inside instead of outside.
You have to count the one inside.
Oh,
no,
no.
because it's not factorable.
We, true, that's why I like this one for your question. It's not factorable, but it's still part of the degree of the polynomial.
I still count.
That was my whole question.
Then I didn't understand your question.
So,
I thought you were talking about roots.
so would that be 3 then?
Nope, that's 5.
No, that's not.
Did it say?
Would that, so the x squared, because there's a 1 on the outside.
Well, why don't we just use the distributive property? Okay, so x squared times x squared plus 1 would give us
3 or 5.
x to the 4th plus x squared, right? And then I gotta multiply that times x plus 4. All right, multiply. X to the 4th times x. So that gives me x to the 5th. That times that would be plus 4x to the 4th. Then this times this. Plus x cubed, and then that times that. Plus 4x squared. Okay, so what's the highest power? X to the 5th, and what's the a value? 1, so that's positives. Yeah, but that's only for even. We don't say word concave up or concave down for odd ones. Okay, so if we were to draw the basic shape, looks like that, right? Except we don't know what happens in the middle. But we do know, so if I erase this, we do know that that's the end behavior. As x goes to negative infinity, y is going to negative infinity. As x goes to positive infinity, y is going to positive infinity. That's the end behavior. Okay? Oh, by the way, what's the y-intercept? Number's right here.
Yeah.
So y-intercept is 0. What's up? Sure. But you have to send your email or tell me what it is. Well, tell me at the end of class. Okay, cool. What's step 2? X and Y intercept. How do we find those? Okay, so what's the x intercepts? Set it equal to 0 and solve. 0, comma. Ooh, but we gotta take the square root of that, so therefore, this is the conversation I had with Evelyn.
That would be.
This one doesn't exist.
Yes. So just before. Negative 4.
So the two x-intercepts are 0 and negative 4. Okay, what's the y-intercept? We said.
Yeah.
And the y-intercept is 0. Multiplicity. So at 0, it does what? That's this one. At 0, it bounces. I'm gonna put a B for bounce. And then at negative 4, it crosses. So at negative 4, it C crosses. Does that make sense? Okay. Number of turning points. So that would give us, n minus 1 would give us 4. So at most it has 4, but it also could have 2. It's not going to have 0. It's going to have at least 1, right? So it either has 4 or 2 turning points.
Okay.
Okay. So I'm going to go to my graph here.
Okay.
My two x-intercepts are 0 and negative 4. We know at negative 4 it does what? Crosses or bounces.
Crosses.
So I know it comes like this, so it crosses through. And then at the y-intercept is 0. And then at 0 it bounces. So that means I have to go up, and at some point I got to go down, but then I bounce, and then I go back up. How many turning points?
2.
Which is one of our possibilities. It either had 4 or 2, and I've had 2. There you go. That's the whole process. Now, what's the unsatisfying part?
Oh, we have to guess.
So we have no clue about that.
This part right here. right? Where is that turning point? I don't know, and I don't care for this particular section. I just know it has a turning point somewhere between -4 and 0. Where is it? It's probably halfway. I don't know. Grab your graphing calculator. Just graph it real quick. Type this in right here. Exactly the way it appears. X squared times parentheses, x squared plus 1 times parentheses, x plus 4. I'm gonna guess it has a turning point at -2. I could throw that in here and see what I get. At -2 squared is 4. -2 is 4 plus 1 is 5. -2 plus that is 2. That's 20. That's 40. I'm saying it happens way up here at 40. Is that what you get on your graphing calculator? Just shoots way up there? Yep. So that turning point way up there, I bet is at 40. I would do a window. I wouldn't do a,
A window?
yeah. Change your y values to positive 50 to negative 50.
So,
50.
40,
50.
50.
And then graph that. Oh, it's even higher.
Okay.
Yeah.
This is what we do.
Yeah.
That's not right.
For number 10?
Yeah.
You gotta show what the equation is.
Don't need that. TMI, I like TMI, but I don't need that TMI.
What do you?
No, the y-intercept, remember, would be the last thing in the polynomial that it doesn't have an x attached to it.
It's.
So remember, to find the y-intercept, we plug in 0 for x's, right? So plug in 0, you get,
You're one of the ones who was gonna.
or
remind
plug in
me.
0 here, you get
No, I wasn't, I thought it was due today.
Can you go back to number 3?
-1. -1 times 4 is times -1/2. The literally number 3? Oh, example 3? Yeah. Okay. So I'm gonna go back to number 3, which is right here. Yeah, Matt, go. Question?
No, we just found a road that we did that really fun, really good joke. And then have really big fun. And then the people say that we enjoyed and double. No, no, thanks for doing it.
Okay, Ish, I'm gonna close this one down right here. You run into any problems, send me an email. Or ask a question when you come back in class.